two concentric circles of radii A and B, where A greater than B, okay, are given. Yeah, it should be where B greater than A are given. The length of the chord of the larger circle which touches the other circle is, say this, two concentric. Concentric means what? They have the same center. Okay. So this is a smaller circle, this is a bigger circle. Now B is greater than A. Okay, so B is the radius of bigger circle, A is the radius of smaller circle. Now this A, B, it touches the bigger circle at point capital A, and we draw a chord from A so that it touches the smaller circle and again cuts the bigger circle at B, and this touch point of smaller circle is, we call it C. Okay, so what do we want in the question? We want the length of AB. Okay, so how? Here important is AB. See this perpendicular from center to this AB means this point C, then you call this OC. That will always be perpendicular to AB, because a segment from center, sorry, this is a radius for the smaller circle, so radius, and this is a tangent, so this will always be perpendicular, radius tangent. Now for the bigger circle, this is perpendicular. So what is the theorem? Any perpendicular from center to a chord will always bisect that chord. So what happens? AC equals to CB, right? It happens that way. So in this triangle OCA, what we get is B square equals to A square plus AC square, right? Pythagoras theorem. Therefore AC square equals to B square minus A square. Therefore AC equals to root of B square minus A square. Now what is AB? 2AC. So AB equals to 2 into root of B square minus A square. That's what is required. That's the answer. Okay. Next, in the given figure, O is a